Welcome back, everyone. So in this tutorial, we're going to look at how you create projectiles. So the idea of my game, it doesn't have to be the idea of your game, but the idea of my game is that you run around as Ralph and you throw snowballs at evil snowmen. So we're going to actually create a snowball entity. Now, we could have created an entity just using the one line such as this, but the thing is, when you create an entity like this, it becomes much harder to actually edit its update and input functions. So I mentioned in a previous tutorial that Ursina will actually run the update and input functions of any game object, being an entity. So what I really want to do is I actually want to create an object that actually extends the entity class and extends its update and input function. So I'm going to actually create a new class and a new file, and I'm going to call it Snowball. And you will actually, if you are up to lesson 4 projectiles from my GitHub, you will have this file here. And what we're going to do is we're going to make it so that the snowball object inherits from the entity class, and then I'm going to use its update function. I actually don't need an input function for this. Because we are using the entity class and we're inheriting from it, we still need to use super, basically so that we also initialize the entity itself. So when I go super init, it's actually going to run the entities init function. And you'll notice that's exactly the same line as if we were actually just creating an entity from scratch. So it's exactly the same line. The difference is that when we create this, we're going to make it so that we can also have its own update function. And the three things I want is that when we create a snowball, I want to capture what is the position of the snowball, what speed is the snowball thrown at, and what direction is the vector that it's being thrown at. So I mentioned previously that when we talk about vectors, a vector is an X, Y, Z coordinate in 3D space, but it can also be a direction. So it can actually be the number of units left, right, and back that something is traveling every frame. So I want to get the direction that the snowball is going to be thrown at. And then in terms of my actual entity, I'm going to create a sphere. I'm going to give it the color white. I'm going to make it 0.5 in width. I'm going to set the position of the entity to the position that we were given. And then I'm going to give it a collider of a sphere. So it's going to automatically have a sphere collider. I don't need to give it a custom collider. The sphere collider will fit the sphere quite nicely. All right, I'm going to have it so that the actual direction, the direction inside this snowball will equal to the direction that has been passed, which is a vector 3D, and the speed of this snowball will be set to the speed that was passed in. So I've given it default values at the moment, but when you create a snowball, you'll pass in the position, the direction, and the speed that you want. So inside the snowball, I've just created some variables for that object. When the snowball's update function is called, and this will be called every frame, the Ursina game engine calls the update function of every entity every frame. So what I want to make it is that the snowball itself is going to update its position based on its direction and the speed and the time between frames. So time.dt is like the time between frames. Now that line itself is a bit mathematical. You'd have to think about it. The position is a coordinate, if you think about it. And then if you've got a vector, a 3D vector, it's going to, every frame, it's going to update the position of this object based on that 3D vector. So if it's changing if it's changing in Y units, let's just say it was changing one Y unit every frame, then within 5 frames, this object here will have moved up 5 Y units. If it's changing 3 X units every frame, then it will have moved 3 X units times 5 to work out what the new position will be. So what we've done is we've done that exact same thing. The direction is the direction vector. I'm adding it to the position, but I'm changing the direction vector and I'm timesing it by what speed is it moving based on the time elapsed. And the time elapsed between frames will be quite a small number. All right, so that's just going to get it going straight. I haven't added gravity yet, and I don't think I will yet. So at the moment, I'm just going to get it so it's just traveling directly straight as an arrow. I'm just going to leave it as is, but I need to create a snowball, and I'm going to create the snowball using the player object because the player itself is the one throwing snowballs. So if I go to the player object, you'll note that the player object, I have got the current input function, and I've left the first person controller's code there. I don't know what's in it, but I know that the WASD key and the space bar are being used. But what I do want to do is make it so that if the left mouse button is down, and it's kind of weird that you say if key is equal to left mouse button down, but that is the actual code from Ursina. Don't ask me why. I'm going to make it so the snowball direction that I'm going to throw is actually going to be the forward vector. So the camera itself, the camera has a forward direction vector. So when I say camera.forward, it's essentially that is the direction of the camera. And just so that it is actually going to go a little bit above where the camera is, because remember the camera's pointing down, I kind of want to make it so it just goes up a tiny bit. The other thing I'm going to do is I'm going to create the snowball at the position of my player. So my player has a position in 3D space. I want to make sure that when I create a snowball, it occurs at that player's position. And then I'm going to actually move that snowball a bit forward so that the snowball is actually going to go forward a little bit in front of you, if that makes sense, because I want to make the snowball in front of the player. And I'm actually going to add 2 Y units so it's a bit higher as well. The reason being that the camera is above the player. So if I want to aim a snowball at the same position or the same angle that the camera is pointing at, I kind of need to make it so that the snowball is created where the camera is. But by all means, play around with this if you want. But I think it works the way it is. And then finally, I create the snowball. So I'm going to create the snowball. You see I can pass it its position. I'm going to pass it a speed, and I'm going to pass it the snowball direction. And now, when I press play, I should now have it so that the actual player, or Ralph, who's the player, will be able to create snowballs. All right, so every time I press space, it's now going, the snowball is moving at the same direction as my mouse cursor on the screen. So essentially, it's been created at the same position as the camera. It's just a little bit slightly ahead of Ralph, and it's going to go wherever I want. But the thing about snowballs is that it should actually be falling to the ground, and they're not at the moment. So these snowballs will exist forever. Nothing's told them to be destroyed. Nothing's told them to fall to the ground. They completely defy all physics. they go straight through the wall. So they're just not proper snowballs at the moment. Right, and we're going to fix that now. So I'm just going to exit out. In the snowball itself, I'm going to add a bit of gravity. And to add gravity, what I'm going to do is the update function is called, remember all entities update functions are called every frame. So what I'm going to do is I'm going to make it so that the direction of this snowball is going to be incremented by -0.3, depends on how strong you want gravity, times by the elapsed time in the frame itself. Because remember, different frame rates are going to have different elapsed times, so you do need to take that into account. And what that means is that as the snowball moves through space, its y direction is steadily going to become more and more negative, which means that eventually it's going to fall. So now I've got gravity. The other thing I'm going to do is I want to make it so that snowball gets destroyed. One of the things about 3D games and all 2D games as well is that when you do create objects, if you just keep creating objects and they're never destroyed, eventually your game will run out of memory because each object takes up memory. So you need to make sure that eventually the snowball is destroyed. And the easiest way to do that is that if the self.position of its y value becomes less than 0, as in it's below ground, it actually gets destroyed. And you can actually just call the function destroy self. Destroy self will destroy this object as if it no longer existed. Right, and so now if we press play, we should be throwing snowballs that fall to the ground. Hopefully. All right, now they're still passing through objects, but you can see that now the actual snowball is falling to the ground. It no longer goes into space, and if I press tab, you'll find that underneath, once they pass through the ground, they are basically destroyed, which is exactly what we want. So at the moment, we're just going to make it so that the snowballs are destroyed once they pass through the ground. At a later stage, what we probably want to do is we probably want to make it so that they hit the ground and they stay there, and then maybe 5 seconds later they melt, and then they're destroyed. So we'll see how we go. But at the moment, we now have projectiles, and I can shoot these projectiles by using the mouse. A challenge for students would be make it so that I can't just throw these snowballs so quickly, because it's a bit too easy at the moment, really. And you can do that simply by creating a variable saying can shoot and using the invoke function to make it so that can shoot is only turned true like 2 seconds after you've thrown a snowball, or a second after. I don't know, it's up to you. Right, I'm going to exit out. That's the end of this tutorial. I'll see you in the next one. Thank you.